All too often, precision agriculture gets overcomplicated. In its simplest form, precision ag and our experience as farmers tells us that we've got variability out in our fields. We've got different soils, and that we can improve our profitability if we manage these soils individually. That's the promise of precision ag. The problem is, where out in my field do these different soils exist? We've tried lots of different ways to get at this, but if we want to manage these soils separately, we need a map, because I generally know the areas in my field and where these soils are, but I need a map to guide my variable rates. And it doesn't matter if you have the fanciest equipment, the most advanced agronomy, or the newest genetics. If we get this part wrong, the map part, if we can't tell the difference between these two soils, we're going to get it wrong. We're going to fail in our precision ag efforts. These two soils came from the same soil survey unit and the same 2.5 acre grid. That means we'd be mismanaging these soils, and that's not precision agriculture. Now, another source of information is remote imagery and even yield data. And while we love using that on our own farm, it's great for diagnosing in-season issues with imagery, and yield data helps us benchmark our practices. But from wet year to dry year, those two maps can flip. They also show the effect of management, like planting date difference or hybrid differences in the field. Even machinery malfunctions will show up. And they make the maps hard to interpret. And so if we want to manage these soils, we need to map these soils. And that's why at Verus we developed a suite of on-the-go soil sensors so that we can scan and map these properties at a high resolution. And we didn't stop at one sensor, because we know that it's not just one soil property that's driving yield and driving these decisions. Soil EC or EM, the texture map, is crucial. You need that. Main driver of water holding capacity. But organic matter also contributes to the plant available part, and it's an important element of the nitrogen cycle. And pH, if we're not mapping pH and managing it at a high resolution, we're leaving yield on the table and we're wasting fertilizer. That's why Verus includes multiple sensors on our platforms in order to capture the most important physical, biological, and chemical properties, as well as topographic features. With this information, we can confidently choose a population of seed for each soil and know that it's going to go in the right spot. We can also adjust nitrogen rates and set yield goals based on soil variations. Same is true for lime and fertilizer applications, and even irrigation management. We've been able to see the benefits of this technology, not just on our own farm, but on farms across the world, from corn in Iowa to kiwi in New Zealand, sugarcane in Brazil to grapes in California. Wherever you are, whatever crop, they can all benefit from the micromanagement of these soils. So we invite you to explore how on-the-go soil sensing can help you and your operation grow more.